So now we're going to talk about elephant toothpaste and the science behind this type of reaction. The people that were involved in this project are Kelly Mahoney, Lydia Osborne, Brianna Tomasi, Gabby Ventura, and Maggie Walriven. Before we talk about what happened in this reaction, we're going to watch it take place. As you can see, there are two bottles. One is labeled cold, the other is labeled room temperature. In both bottles, there are dish soap, hydrogen peroxide, and food coloring. The only difference between the two bottles is the bottle that is labeled cold has hydrogen peroxide that was kept at a cooler temperature, while the bottle that is labeled room temperature, the hydrogen peroxide was kept at room temperature. Now, as we watch, Brianna is about to add potassium iodine, and this is going to act as a catalyst in the reaction. Now, we just saw that the bottle that had hydrogen peroxide that was at room temperature reacted faster than the bottle that had a hydrogen peroxide that was kept at a cooler temperature. We're now going to perform a splint test to see what gas is being released from this reaction. As we watch, the flame is growing brighter, and it is not going out even when it is put in this foam. This means it is being tested positive for oxygen gas, if you can remember back to when we performed splint tests as well. As you can see, there's a size difference in these two bottles. The bottle that is labeled cold was the bottle that we used in the reaction that took place. As you can see, it is smaller than this bottle, and this is the originally sized bottle this was at. So we want to wonder why this happened, and we're going to talk about that and a couple other things in this presentation. So the branch of chemistry that deals with the rate of reactions are kinetics, and that is the chemistry that we're going to be exploring today. Another thing we want to know is what a catalyst is. And a catalyst is a substance that speeds up a chemical reaction but is not consumed by the reaction. Now we're going to want to ask ourselves a couple questions during this presentation. One is, how do catalysts speed up reactions? Why does this happen? The second is, why does an increase in temperature speed up reaction? And the third is, why at the end of the presentation after the reaction did the bottle shrink? First, we're going to talk about catalysts. In this experiment, potassium iodine was used as a catalyst. There are two types of catalysts, homogeneous catalyst and heterogeneous. A homogeneous catalyst is a catalyst that is the same phase as all the reactants and products in the reaction system. A heterogeneous catalyst is a catalyst whose phase is different from that of the reactants or products. So in this example, potassium iodine was a heterogeneous catalyst. So what exactly do catalysts do? They increase the chance of particles meeting, and this causes there to be a decrease in activation energy and results in an increase of the rate of reaction, which speeds up the reaction. Now, temperature was also a factor in this reaction. Heating a chemical substance can make the molecules separate and move around faster, and this can increase the speed at which they mix with the surrounding molecules from other chemical substances, thus speeding up a reaction. An elephant toothpaste, when the hydrogen peroxide was at room temperature, it reacted faster than the one at cool temperatures because of these reasons. Lastly, we're going to talk about why the bottle shrunk size. When you apply heat to any plastic, it causes it to decompose and the bonds break and the plastic melts. That's why when you throw a bottle into a fire, it will melt. So at the end of elephant toothpaste, the plastic bottles shrunk, and this is because when plastic bottles are made, they're made by stretching out plastic using heat. So when it was heated again, it caused the bottle to decompose back into the original state the plastic was in before it was made into a bottle. And that is the end of this presentation. Hopefully you now understand the different types, all the different things that can affect rates of reactions. Here's our references that we used in this presentation. We have websites on the actual experiment taking place, catalysts, temperatures, and why those bottles got smaller. Hopefully you enjoyed watching this presentation. Thank you.